Okay, welcome back. I hope your breaks were good. Today we are starting with trigonometry. All right, so we're not diving right into it. We'll take it slow. Um, okay, but this is the meat and potatoes of precalculus. All right, before calculus was an integrated subject in high school, precalculus was trigonometry. So normally you'd spend a whole year going over this stuff. But I guess over time they decided that it didn't deserve a whole year or whatever, and they crammed a whole bunch of other stuff into it. So probably for the definitely for the rest of the second marking period, and for a good chunk of the third marking period, we're going to be talking about trigonometry. All right, but like I said, we're going to take it one step at a time and make sure we get it along the way. So the first thing that we're going to talk about is the basics of trigonometry, and that is angles. Okay. Trigonometry, there's a couple different ways of looking at it. It is the relationship of triangles. Okay, triangles, anometry. I don't know what that means, but math. But the relationship of triangles translates to a lot of things in real life. When we get there, I'll mention it again, but we use trigonometry in things like sound. Okay, anything that, honestly, anything that has to do with waves in physics, we can implement trigonometry into it. So as we move along, there'll be more and more things that we can tie into real life. The first thing we're going to talk about, though, is angles, right? The start of it. So some of this hopefully should be, you might not have, should be refresher from geometry, okay? But it might have been a while since you've seen it. So like I said, we'll take it slow. So the first thing is, what is an angle? All right, there's two ways of looking at an angle. Well, the basic angle, right? We need two rays. Okay, so if you remember, a ray has a starting point and then it continues on forever. Okay, so an angle is normally made up of two rays. We call one side the initial side. We call the other side the terminal side. Okay, and where they meet, the point that they meet, we call the vertex. All right, so that word should be a little familiar with you. We see vertex and vertices in geometry, right? It's the corners of our shapes, right? So a triangle has 3 vertices, a square or a quadrilateral has 4. It's just where two lines intersect, all right? And then we measure the angle. We start at the initial side and we end at the terminal side, right? And that's why they're named like that, right? That's what it implies. The initial side is where we start and we end at the terminal. All right, so this is your basic angle. We, for the most part, are going to be looking at angles on the X and Y axis. Okay, and this may be familiar from Algebra 2 when you guys did the unit circle. All right, we will be revisiting that. So when we have the X and Y axis, okay, we say that this is standard position. All right, so we're making it so it's nice and neat and it's easier to read, right? Because if it's like this, I mean, not that it's hard to read, but this isn't its proper form. So for standard position, our initial side is always going to be this half of our x-axis. Okay, so our angle is always going to start on that line. And then the second part may be wherever. Okay, maybe over here. All right, so that would be our terminal side. And now this is much easier to measure the angle that way there. Okay, we still have the vertex, but now our vertex is always going to be at the origin. Okay, our vertex is always at that point 0, 0. Okay, when we are in standard position, okay, we always, if we're talking about our angles, we always go in a counterclockwise measurement. Okay. Right. So we always start here and then we go up and to the left and then we bring it around. All right. So if my angle's there, right, we start here and we go to there. If my angle's down here, right, I would still start here and go all the way around to this way. Okay. That is for, let me say this. Okay. When we have positive measured angles. If we have a negative angle, okay, that just tells us that we go in the opposite direction, right? So if I said negative 30 degrees, I would start here on this line, right? And then I would go clockwise. 30 degrees, and there would be my terminal side. What's nice about this is that even if we have a negative angle and we move clockwise, there's always going to be a positive measurement that ties along with that, right? If I go negative 30 degrees this way, well, I can also measure it going clockwise, all right? And that would be 330 degrees. Because what do we know about a full circle? How many degrees is in a full circle? Do we remember?
360.
360. Right. So if we come up with a full rotation around our standard position, all right, that would be 360 degrees, correct. There is a name for angles that meet up like this. Okay, so negative 30 and 330 we call coterminal angles because they end up in the same place and they share terminal sides. Okay, so coterminal, right? Co means usually shared. So we might have some angles that we end up in the same place because we're dealing with 360 degrees of rotation. All right, so we have, now we got to be careful. I can't say that negative 30 degrees and 330 degrees are equal because obviously they are not. They are different numbers. And if I wasn't talking about standard position, they would be completely different. But if I'm specifically talking about standard position angles, okay, we do say that they are coterminal angles, and they would give you the same angle, right? If I mapped out these, it would be the same thing. It would be this angle here. All right. Some names. Some variables. I'm not sure how much you got into it in algebra and geometry. You might have seen it in geometry. One common symbol that we use is the Greek letter theta. Right, so it's a circle with a line through the middle. A lot of times, if I'm doing it quick, you'll see it'll look like that. Okay, it's just a Greek letter. We like to use that instead of X and Y's, well, because here we have X and Y. Other letters are used for other things. So a lot of times we use theta to talk about angles. All right, so you'll see that a lot. If we need more than one name, right, if theta is taken and we need some more names, we go to some more Greek letters. We use alpha, which is kind of like a, well, I mean, it's a Greek A. All right. I do it like that. You might see it differently. You might see like a fancy A like that. I'm trying to get how they draw it in the book. Okay, something like that. I draw it like that. It looks like, like a goldfish kind of deal. That's alpha. Or a fancy B, and that's beta. Okay, so those are just two other Greek letters that we use that you might see pop up either on a worksheet or I don't remember if it's on the final or not. I got to take another look at that. All right, so those are just names that we use. So just a heads up. Any questions so far? All right, so let's get into some formal definitions here. All right, so formally, the amount of rotation from the initial side to the terminal side determines the measure of an angle. Okay, so technically, what we're doing is rotating. All right, and that'll come into play a lot later. All right, so are you guys familiar with radians? Did you guys cover radians in Algebra 2 at all? Do you know what a radian is? Okay, hopefully I'm going to take that as a no. Hopefully, though, you are familiar with degree measurement, right? And that's normally how we talk about angles. We talk about degrees. Okay, we use the symbol, the little O, right? So that would be x degrees. Okay, so 1 degree is right. We said 360 total degrees in 1 full rotation. All right, so 1 degree is 1/360th of a rotation. All right, so that's how it's kind of defined. I don't have much to say there. Okay, but so, right, degrees is one way to measure. The other way to measure, actually, there's a few ways to measure, but another popular way to measure is something called radians. All right, so radians has to do with pi. Okay, anytime we're dealing with radians, more than likely pi is going to be part of the value. All right, so for radians, 2 pi radians is 1 full rotation. Okay, so there we have a conversion. That will pop up later. Okay, 360 degrees is 2 pi radians. Now you have to write radians afterwards. All right, it has to be there. You could just put rad, R-A-D. All right, so if you said 2 pi rad, that would be fine as well. You don't have to do radians the whole time. Okay, but radians is really important in geometry and trigonometry because of this number, right? I couldn't find it earlier. I will show you tomorrow. There's a pretty cool explanation on why we use radians, but I'll try to do my best right now. All right, so we have some circle, right? We have in that circle, of course, any circle, we have the radius, right? R is our radius here. So 1 radian, all right, without the pi. If I want to measure 1 radian, what that means is I take my radius, right, and I measure that length, whatever that length is, I measure that out on the circle. All right, so however long this is, right, maybe it's 2 inches, whatever it may be, I measure 2 inches going around. Now, in geometry, hopefully you learned that along the edge of the circle, along the perimeter, we call that the arc. Right? So if I'm measuring from one point of a circle to another point on that outside, that is the arc. So here our arc is the same as our radius. The angle that creates is 1 radian. Okay, so that's where we get the term radian. This measurement is if we took the radius along the edge of the circle, and it's the resulting angle that we get. So here I have 1 radian. If I take this little, this little pie triangle here, like a pizza pie cutout, right? I can fit in this top half, I can fit exactly, all right, and again, I'll show you with, hopefully I can find the infographic, the thing tomorrow. I can fit exactly 3.14 radians in this top half of the circle. That 3.14 is pi. All right, so I can fit pi radians up here in this top hemisphere. Okay, so that's a name a word you might hear pop up. Hemisphere just means half of the circle, right? Half of the. So if there's 3.5 radians at the top, that means I can also fit 3.5 radians. I'm sorry, 3.14 radians down here. So together, the top and the bottom, we have 2 pi radians, okay? Or 6.28 radians for the whole circle, which is 2 pi. And so with that, without doing any, physical measurements, right, without getting out a protractor, we can calculate the angle by dividing the arc length by the radius. Okay. So from this definition, from this formula, all right, which we'll come back to tomorrow, we can see that when S is equal to R, when those are the same, then you have 1 radian. So when the arc length that you're measuring, which is what we're going to be doing, this is how we're going to start off, okay? When that measurement is the same as your radius, then you have 1, oh, I forgot it, 1 radian. Do I have enough time? No, I only have 2 minutes. Okay. All right, so there's a very basic introduction there. Any questions?